Hello, my name is Mark Ramsey. I'm the managing partner of Ramsey International. Ramsey International is an advisory firm focused on working with clients in the design and deployment of large-scale data analytics platforms. We work a great deal with Cloudera CDP, and in fact, in 2021, we're named the Partner of the Year. With that, let's move on to today's topic, which is deploying a modern data analytics platform using Cloudera CDP. Today, we'll really talk about three things. One is, what is a modern data analytics platform, just to kind of level set. And then the second is how CDP changed the deployment paradigm. And lastly, it's around how to avoid POCs. And this is probably my favorite one. It's getting to time to value faster and not wasting time on POCs. And I think these three topics actually directly align with the theme of Cloud Hour Now, which is think bigger, move faster, and go hybrid. So first, let's talk a little bit about the major components of a modern data platform. First, a modern data platform is delivered as hybrid multi-cloud. And this really allows us to have maximum flexibility, but also focus on cost effectiveness. The second component is the data fabric, and the data fabric allows us to really focus on the entire data landscape of the organization. Third is the data mesh, which is an organization that allows us to deliver data products much faster than previous approaches. Next is the data lakehouse, which is a way for us to take the data products and deliver those to the consumer in a variety of formats to support really a portfolio of analytic tools. And finally is around data observability. And data observability is connected to access and resource management. So those two together really focus on across the entire data ecosystem. Now, since data observability is a newer topic to the modern data platform, let's spend a little bit of time and dig a little deeper into the 5 pillars of data observability. First is around freshness. And what this means is how current is the data that is in the platform compared to source data. But it also helps us understand the frequency of update of source data and how we're leveraging that within the modern data platform. Because you may have what I like to characterize as dark data, which is data across the ecosystem that really is not being used and is not changing. So it's a great opportunity to prune that information from across your data landscape. The second is distribution. And distribution is one of the first data quality aspects of data observability. Distribution relates to how the data in each attribute is statistically distributed. So, for example, if we're talking about age, is the age, if let's say the age is in the range between 16 and 95, and then suddenly you receive a piece of data that the age is 150. This could be an indication of a data quality problem. And so this is really something to continue to monitor within your data ecosystem. The second metric or pillar of data observability that aligns well with data quality is volume. And really what volume means is understanding the flow of data in each of the sources. So for example, if it's the customer master file, and each day on average, there's maybe 2 million updates to that customer master file, and then suddenly there's 20 million or 200 million. It's a great way to alert the organization as to a potential problem within the data ecosystem. The next is around schema. Now, schema and schema drift have always been an issue related to data analytics solutions. Within data observability, this is to really push this to the forefront, monitor the schema within the source systems and as the data flows through the ecosystem, and really understand the rate of change of schema in the source and whether that has an impact downstream to the data product. And then lastly is lineage. So lineage is understanding really from the very creation of an attribute in the source all the way through the delivery of that attribute in the data product, what changes, updates, modifications have been made to each and every attribute in the ecosystem. So these 5 together constitute the really data observability or monitoring of the flow of data across the entire ecosystem. Now, with those components, there's some confusion that folks have that these components are either or, so that you either do a data fabric or you do a data mesh, or you implement data mesh or you implement a data lakehouse. And I think that confusion we really need to tackle. So let's do that by first showing what we use at RI for a modern analytics architecture. So on the left-hand side, it represents the full data landscape of the organization. So this is internal and external data, structured and unstructured data. So all of the sources from across the organization. The first step in the process is to inventory that data, profile that data, and then selectively ingest that data into what we like to call the foundation layer. Now, some organizations refer to foundation as the raw zone, the staging area, the data lake. It doesn't really matter what it's called. It's really where the source data comes together in a common location to really be used as the raw materials for the platform. The next step in the process is between foundation and what we refer to as integrated layer. And that is really the curation, harmonization, and standardization of the raw data into data products that then align to the business needs. So that part of the process, again, goes through and takes the raw materials and packages it, sometimes into industry models, sometimes into internally developed models, but it's really packaging the data in alignment with the use cases of the organization. And then lastly, on the far right-hand side of the diagram, it's the consumption of the data. And so these will be the collection of tools that are used by the data consumer to access those data products. And in support of this, it needs to be a very elastic layer to support the ebb and flow of volume of users that are really going to be accessing the data. So with that as the foundation for our discussion, let's talk about the components of the modern data platform. First is the data fabric. And the data fabric is the architecture and the data services that really help us from source data all the way through to data products. So these will be the technologies, and normally this should be data-driven pipelines so that we get that flexibility to really accelerate the delivery by using pipelines that are driven by the data itself versus, custom written code and things that we've done over the years. So the data fabric lays that foundation from source through to the data products. The next component is data mesh. And you'll see that data mesh actually lays over that component of the fabric from the foundation through curation and harmonization into the data products. Data mesh is not a technology. Data mesh is an organizational design and an approach that uses the technology of the data fabric to create the data products. And the individual teams that are aligned to each data product allow us to deliver the data products much faster because it's being done in parallel versus the traditional way of doing curation, which is very single-threaded. The next component is the data lakehouse. The data lakehouse is that connection point from the tools and technologies that the data consumers are using into the data products. And really, as the name suggests, it's a combination of a data lake and a data warehouse. And the reason it's called that is because the data products are stored in a flexible format, and the consumer and the tools that are being used, it's virtually delivering the format that's needed. So in many cases, relational databases are what a BI tool may expect, and the data in the product is not stored in relational format. So the data lakehouse capability is to virtually deliver the data in relational format to the tool that's being used without the intervention of the data consumer. So it's that elastic layer that allows us to connect the data products to the variety of tools, whether those tools are AI and machine learning, if they're a graph database, if it's a dashboarding tool, other type of BI tool, reporting tool, so forth. And then across the entire data ecosystem, we have the monitoring capabilities of data observability, which helps us understand the quality and the reliability of the data that's flowing across the ecosystem. So those things coming together really constitute a modern data platform. Now, let's switch gears here a little bit and talk about an actual example of delivering a modern data platform using Cloudera CDP Public on AWS. And this example is for a top 10 pharma company. But just let me mention that even though this is for a pharma company, the technologies and the approaches are not pharma specific. So certainly the data products that this organization created are specific to pharma. However, all of the other modern data platform components are really industry agnostic. It's just the creation of the data products where it becomes very industry specific. So this is a relevant example, whether it's pharma or banking or insurance, the approach is exactly the same. And in this particular organization, the first release of their solution was done in less than 6 months, and the full production release for the environment was done in less than 1 year. That was only possible because of using CDP Public on AWS. This example is made up of hundreds of structured sources, hundreds of thousands of tables, and hundreds of unstructured data, all coming together into a single repository, a single delivery mechanism for the organization. Now, that was made up of a number of data products that align to certain business use cases, but it all came together into a single platform. Let's talk a little bit about this particular solution. So we'll start again with the architecture. Then I'll overlay that with a number of the components that were used for this particular solution. And you'll notice that we use many of the Cloudera CDP components to form the foundation, and then combine that with third-party solutions to deliver some of the specialty. If we start on the left-hand side, the data inventory, profile, and ingestion was executed leveraging the Cloudera data engineering experience, data engineering clusters, Solar, a number of the main CDP components, and a lot of that work was orchestrated using the Nabu product from Modak. So Nabu developed the pipelines that were then executed within data engineering experience. The data was moved between the source systems and into Foundation. The Foundation in this particular case was using the S3 object store. Now the S3 object store was under SDX control, so all of the access management, all of the encryption, all of those things were managed through SDX. Then the step going from Foundation into curation, so that was executed by a data mesh approach, and again using Nabu as the orchestration component, and developing those pipelines to move the data from Foundation into the data products that were delivered in the integrated layer. And then finally, from a consumption standpoint, consumption was delivered using the data discovery cluster, so using Solar, and then also the data warehouse service, as well as the machine learning service. So all of those were coupled together to deliver the elastic layer and the data lakehouse. And those were combined with third-party solutions, including Neo4j and the Drug 360 component from Telek. So all of those came together to deliver these. But the key acceleration point was around using a modern data approach to automate and accelerate on top of CDP as the foundation. Now, this has been a significant paradigm shift, moving from a traditional way to deliver these platforms to a hybrid multi-cloud approach. So I had the opportunity for another top 10 pharma to deliver a large-scale platform on par with the example that I just shared, but that was done in 2016, and it leveraged Cloudera CDH on-prem as the delivery mechanism. For that solution, the actual delivery took 12 to 18 months, incorporating all of the different components that have to happen to build out the solution. So 12 to 18 months for a on-prem CDH-based solution. The example that I just shared with you was started in 2020 and the production release was in 2021. That, as I mentioned to you, was done in less than 6 months. So let's call it a 4 to 8 month window. So literally collapsing the time in half by switching paradigms to doing hybrid multi-cloud versus doing totally on-prem. And to continue that acceleration, within Ramsey International, we have developed an automation solution called Daedalus that now allows us to do the design work in a matter of days and do the deployment in a matter of hours. So going from years to months to hours. And really that paradigm shift is driven primarily through hybrid multi-cloud and leveraging Cloudera CDP. So let's walk through an example of moving away from doing POCs and really accelerating that time to value by using Daedalus to deploy the environment. Many organizations over the last number of years have focused on doing proof of concepts. Now, a proof of concept has really been for the organization to get comfortable with the technology, try it, and do it on a small scale so that it didn't take a long period of time, and they could really vet out whether the technology did what was claimed that it would do. The problem with proof of concepts is that they really focus on that demonstration of the technology, but they're very small scale and they're never production ready. And literally you spend the time, let's say you do a 3-week POC or a 2-month POC. At the end of that time, the POC is a throwaway and the time you've invested is a throwaway. So our recommendation is to move directly to what we call a proof of production and move away from a POC. And the only reason we can do this is because of the ability to leverage Cloudera CDP with full automation and full integration with third-party tools. So literally you build the production environment and add your data and really try that. And if it works fine, you have the platform, you can continue to use the platform. If you have issues, you can pull the plug, but the time that you've invested and the resources of your investment are the same as doing a small POC, but you have the option to just continue forward and use the platform in production. So let's talk about how this works. And so again, I'll use the architecture diagram that I shared earlier, and I'll walk through the major steps that happens with a Daedalus automated deployment. So first, the underlying requirements on the cloud provider are put in place. So this would be things like network, VPNs, VPCs, service accounts, basic things that happen at the cloud provider level. The next is to use CDP to build the environment, implement SDX across the environment, build the base data lake. The next step is the automation of a lot of the characteristics that factor into production platform. Things like service accounts, the directory structure within the object store for the foundation and the integrated areas, the creation of the underlying access mechanisms. All of that is automated and created. And then in parallel, all of the CDP components are implemented. So this would be one or multiple data clusters, one or multiple data services. All of those are deployed in parallel on the platform. And then finally, the third-party software is installed and integrated into the environment. So all of this happens within a matter of hours, and it's up and ready to go. And so basically, you just add your data into the environment and begin to use the entire ecosystem. So the entire modern data management platform is ready for your use. So the way we approach this is to kind of really keep it simple and have kind of a 1, 2, 3 model. So step one is to do a design of the entire modern data platform. So this is all of the CDP components, all of the cloud, all of the on-prem, all of the capabilities that are required to deploy. Everything is brought together into a single location. Second, and I think this is probably the most important step, is to confirm that the design that has been created can actually be deployed into the hybrid environment. So do you have enough access rights? Are there enough resources available in your cloud? Are the passwords properly configured? Are the account specifications properly done? Do all the right accessory files exist? So confirm that everything is ready to be deployed and can be deployed. And the second part of it is really do a projection of the cost of running the environment if you deploy it. So this assembles a cloud cost. So let's say, for example, you're going to be deploying on AWS. It will list all of the AWS charges that are projected for the platform and all of the Cloudera CDP charges that are projected for the platform, so that you have a really good understanding of that baseline as well as any kind of burst capabilities on the platform. So all of that happens before you actually deploy the environment. And then lastly is actually the automated deployment of the environment, which I mentioned before. So let me go down just one level. So the design is all captured in a single JSON configuration file. Datalist has a user interface that allows you to walk through and make decisions on all of the aspects of the deployment. Captures all of that into a single file. That file is then fed into the pre-check process prior to deployment, which checks all of the underlying characteristics. But then as shown here on the screen, it also creates the estimates of your base and burst cost ranges for your cloud provider as well as for the CDP platform. And then of course the total of what your total cost for operating the environment that you're getting ready to deploy. And then lastly is the actual deployment. And on your screen, you see a visual where in the upper left is, in this case, the AWS console, where we can monitor the instances that are created within AWS. On the upper right is the CDP management console, where we can watch the activities from CDP. On the lower left is Dataless, the execution window for Dataless. And on the lower right is the architecture diagram, where we update as different components happen. Now, we don't have time today to actually show you the video, but if you would like to see more information, if you go to the Cloudera Solutions Gallery and search for Ramsey International, in the catalog entry, at the very top, you can click on a link to watch a video. It's about a 4-minute video that shows the construction of an entire environment using this construct with the 4 windows. So I would invite you to look at that if you're interested. And then after deployment, there's a number of things that are more post-deployment management. One is around group synchronization and managing the volume of groups. A second is understanding the databases that are in the ecosystem. And the last is really understanding all of the instances that are active within the environment. So Dataless also includes modules that are post-deployment to really help bring all of this together. And for example, on the group distillery and synchronization, that is an automated module that connects all of access control and resource control into Active Directory. So it's an LDAP interface to really synchronize all of user management within CDP with your Active Directory specifications. Makes it so much easier for delivering access control. Most importantly, as I mentioned at the beginning, a modern data platform must support hybrid multi-cloud deployment. And that gives us maximum flexibility in the way we deploy the environment, but it also gives us cost effectiveness. So as illustrated here, it's extremely important when you step back and look at your modern data platform to take into consideration deploying on private and multiple public clouds as really your way to manage that flexibility but also cost effectiveness. So as we've discussed, deploying a modern data platform really requires the use of a hybrid multi-cloud architecture. I'd like to thank you for your time today.